Hello, Algebra 1 students. Almost said Algebra 2, and this is definitely not for my Algebra 2, but for my Algebra 1, this is our video on the coordinate plane and understanding graphs. So we're going to kind of crash course back through the coordinate plane and how to graph points, which by the time you're watching this video, we will have already looked at that in class anyway, but there's some good vocabulary that you need to commit to memory in here. And then we're going to go over drawing graphs to relate two quantities together. Okay, the coordinate plane is called the Cartesian coordinate system after a man named René Descartes. And you would have an extra E here if this was a female name, René in French, or René if you want to make sure that you pronounce it correctly. And Descartes, I do love my French pronunciation. He was a 17th century French philosopher and mathematician. He was famous for the quote, "I think, therefore I am." And the kind of parable goes that he had an issue where there was a fly flying around on the ceiling. A fly, and it was flying around on the ceiling, and he started to think about how he could take and he could locate that fly on the ceiling using kind of a grid system. So supposedly, this is back before TV, internet, etc. Supposedly, he was using his mathematical knowledge to think about how he would locate that fly on the ceiling if he had a coordinate system. But I don't know. That's one of those stories that, I don't know if that's really true or not. But it's kind of cool because you could think about that little fly. Map makers in ancient Greece had a coordinate system way before that. So Descartes was not the first one. He was just the first one to use it in a way that caused people to name the coordinate system we use now for him. And the coordinate system was the very first real link between the algebra and the geometry sides, where you could actually see the algebra. Your basics for the coordinate plane, you have your x-axis, that's horizontal, your y-axis, that's vertical. The origin is the point 0, 0. So the origin is the point 0, 0. Make sure you remember that. And there are 4 quadrants. Quadrant 1 is positive, positive. So this is your positive, positive quadrant. This is your negative x, positive y. And you'll notice that quadrants, it goes around in a big C. It goes counterclockwise. So 1, 2, the third quadrant is negative, negative. And the fourth quadrant is positive for x, negative for y. And our ordered pairs, the x and y coordinates, we know come in ordered pairs, x, then y. And this is not required vocabulary, but I had to learn it back in the dark ages. The abscissa is the x, and the ordinate is the y. So the abscissa and the ordinate is another way to call your x and y coordinates. So just to crash course again back through graphing points, you do not have to copy this diagram unless you choose to. We have ordered pairs here. Here's A is the ordered pair. Let's count it. 5, 3. Remember to count the x first, the y afterwards. Coordinate for B right here. What's that one? Negative 3, 1. Okay, how about C? Negative 6, negative 4. D. D is on the y-axis. So D has a, whoop, I didn't mean to write right there. D has an x-coordinate of 0, because you don't go to the right or the left to get to it, and a y-coordinate of negative 3. E is the origin 0, 0. F, 4, negative 5. Negative 5, there we go. And then G is similar to D. D has a 0 for the x-coordinate. G is going to have a 0 for the y-coordinate. G is actually, oh, look at that. It's actually 6.50. Huh, that's odd. Or a decimal, not really odd, but anyway, that's just the basics for graphing points. Now, by the time you watch this, hopefully you've already gone back over that. Now, we're going to move on to using graphs to show relationships. So once you have the idea of the x and the y axes, let's look at how we can actually take a graph, take a real-life situation, take a graph to represent that real-life situation. We use coordinate graphs to visually represent relationships between two variable quantities as they change. You can use tables and graphs, and both of them show relationships between variables. You'll also learn about relating tables and graphs. The variable represented by the x value, that is your independent variable. So the x value is the independent variable. The y value, that is the dependent variable. And I switched colors so you could make sure you saw the difference between the two. X independent, y dependent. X independent, y dependent. The way you can think about it is that most of the time when we give you guys equations, we have you plug in the x. The x is the input, or the independent. And then you have the function machine, and you'll remember function machines from previous years. And then you have the output, or dependent variable. And the dependent depends on the independent. So this is the basics of what we're going to do here. So the graphs here below indicate the height of the water. So y-axis is height of the water that goes into each container, because we're going to be filling them. So if you fill the container over, this is the height of the water compared to the volume of the container. Compared to the volume of the container. Okay, so which one relates to which? Well, start with graph number one. Graph number one. Well, let's see. It's filling. The height is going up, and then the height continues to go up, but not as quickly. So that indicates that the volume there, that the size of the container seems to somehow be getting larger. That's this one right here, because the height of the volume of the liquid, inside this container steadily increases. But then when you get to here, the height doesn't go up as fast, even if the water's going in at the same rate, because it's wider. It fills more space in horizontally before it does vertically. So this one right here is most definitely the graph for C. So we've used that one. On this one, the height is not very high, but as the volume increases, the height goes up, but it's just not that high. And then this one, the height is much higher. So I think that should be pretty easy to see. This has got to be A, and this has got to be B. So that's the basics of what we're doing. Let's take a look at another graph. This time we're going to describe what's happening. So we have the situation, we have the graph, and we need to describe it. The graph shows the volume of air in a balloon as you blow it up until it pops. What are the variables? Let's start with that. The independent variable is the time, because the volume of the balloon changes over the time. So as the time changes, the volume changes in turn. And the dependent variable, that is the volume. And this goes right in line with what we learned. Independent x and dependent y. Then it wants us to describe how the variables are related at various points on the graph. So let's take a look at this. So here, the balloon is empty. We haven't done anything to it. We haven't put any air in it at all. Here, and here, and here, someone is steadily blowing air into the balloon. So they're steadily blowing up the balloon. What's happening at these points? Here, here, and here. What is the person doing? The person stops to breathe. You can't blow up a balloon nonstop. You guys are pretty full of hot air, but you can't blow up a balloon nonstop without stopping to breathe yourself. And then, this is probably pretty obvious, but what happens here? Because you're blowing up the balloon and slam, the volume goes down to nothing. What'd the balloon do? The balloon popped. Two P's and popped, not P-O-P-E-D. That would be the balloon poped, and I don't think you can pope a balloon. Anyway, it popped. All right, so that gives you the idea of what happened to our balloon. This is our last slide and the last of the graphs that we're going to see for this concept. And actually, it's a graph we're going to draw. So we're going to start off by reading a model rocket. So this is a rocketry problem. A model rocket rises quickly, then slows to a stop as its fuel burns out. It begins to fall quickly until the parachute on the rocket opens, after which it falls slowly back to Earth. What sketch of a graph could represent the height of the rocket during its flight? Label each section. So let's start with a graph. This is the time as it passes. Okay, so the time of the flight in seconds. And over here, we're going to have the height of the rocket. And we don't know what we're measuring the height in. Let's just measure it in meters. And it starts off on the ground. And when it launches, the rocket rises quickly. And then its fuel burns out. So it starts to fall quickly. But then the parachute opens, and all of a sudden the rocket can gently float calmly and steadily back down to Earth. So there's the basic idea of the graph. Now let's fill in some description of what's happening. First of all, this is 0 for height and 0 for time. So it starts off with 0 there. In this section of the graph, the rocket is rising quickly. It's rising quickly. So it takes off and it's rising quickly. All right, in the next section of the graph, right in here, this is where it stops rising because the fuel burnt out. So it stops rising. And for a few seconds, instead of rising quickly, it's falling quickly. At this point, what happened? Well, based on what it says up here, it was falling quickly, and then the parachute opened. So at that point, that's when the parachute opens, and the rocket falls slowly to the ground. So we can describe these situations. You're going to need to be able to match graphs with situations, to sketch graphs to describe situations, and write out situations that are illustrated by graphs. Hope this was an easy and quick video for you. I'll see you guys in class.